Welcome to Pure Mathematics 1, Chapter 7, Trigonometry. Topic: the sine, cosine, and tangent graph. So first of all, we'll go and look for the sine graph. The sine graph. Now draw a scale. Here. Okay. So you should notice that the sine of x greater than or equal to 1 or minus 1 and smaller than or equal to 1. It cannot be bigger. So here 1, here is minus 1. So the sine of x only oscillates from 1 to minus 1 and vice versa. So first of all, you know that the sine of 0 equal to 0 degree, and you also know that sine of 180 degree. And these things you can use your calculator to find out, and you have 0, 2, and then you have the sine of 90 degree equal to 1, and then you have the sine of 270 degree equal to minus 1. So I plot the point in here. So first of all, I have 0 with this one. Here's my 90 degree. Here's my 180. And here's my 270. And the last one is sine of 360 equal to 0, 2. Here, 360. So how do it look like? It look like something like this. So it will be this one. Go from here, cut through this point. Here, the maximum one will be 1, will be sine of 90. Here is sine x, and here the minimum one is this one, down to 270 degree. So we would draw the sine graph of a function depending on the condition. Let's say they give it the condition from minus 90 degree greater than or equal to x smaller than 90 degree. So we would draw the part of the sine graph will be something like this. Here's minus 90. So the one will go from here to here. So only this part count, and the other part we don't have to care about. So from the sine graph, if you have the sine, let's say you have sine x equal to 0.5. So in the scale 0.5, you read off from the graph, and you can find the values of x, which is a degree. You can find this value. Actually, we cannot draw a really precise sine graph, so you should use a calculator to find the exact number of this one. We just have an idea that when sine of x equal to 0.5, we'll have the angle will be this one. Let's say if you have the sine of x equal to 0.52, so you have another values will be this one. If now it extend the range to 9 from 0, x smaller than 360. So when you have your sine x equal to 0.5, and you will have two values of x, because here in the line is 0.5, cut the graph twice from 0 to 360. It cut the graph twice, so in this point we have another angle here, which is called angle M. So this angle would have a sine M equals 0.52. So by looking at the graph, you can identify that how many roots you will have for a function. In conclusion, you should remember that the sine graph is something start from 0 up to the maximum at 90 degree, and go down and cut the x-axis at 180 degree, and it go down to the minimum, which is minus 1, and go up to 360. We can draw it to any boundary that we want. We can draw the sine graph based on the interval that we have. let's say I have the interval like from minus 180 to 180 degree. So I would draw from here minus 180. I can extend this one into any shape. So the overall shape of this one will be something like this. Here, 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 here. Just depending on the interval, so we can choose which part that we will work on. Let's say we have here was 360, and they say they wanted to work from 360 up to 720. So we will choose this interval here to work with. You can extend the sine graph to any level that you want in order to help you to work with your question. But in the exam paper, they don't want you to work with such a big range like this. It's just something around here. And now we will talk about the cosine graph. Cosine graph, which is a graph of cos x. And please also notice that cos x greater than or equal to -1 and smaller than or equal to 1. This one is a general rule. So I have my scale in here. So I would plot 1 and -1 first. And now I would find some point in order to illustrate the graph of cosine. I have cos of 0 degree equal to 1, and then I have cos of 90 degree equal to 0. And the number you can use the calculator to find. And cos of 180 degree equal to -1, and you have cos of 270 equal to 0, and the last one, cos of 360 equal to 1. And I have 90 here, 180, 270, and 360. So my cos of 0 will be here, and I will draw the curve which is this one. Here. Start from 1 and go down to -1 at 180 degree and go up to here. But basically the shape is quite the same. Let me draw some more. Here is not -90 degree, and here's -180 degree. So it would be like this. Here's a 450 degree. Okay. The shape of the curve, the sine curve, would be this one. Here, something like this. These two look quite the same, but they start at different point. So when x equal to 0, mean 0 degree, the starting point of the sine graph would be from 0. But for x equal to 0, where it is 0 degree, the starting point of the cosine graph start from 1. So from here, if I have something like cos of x equal to 0.3, which is this one, so it cut the graph at 2 positions. Let's call this angle is angle A, and angle here is angle B. So cos A will equal to cos B equal to 0.3. So the 2 points here, A and B, is when I have the interval where x greater than 0 or equal to 0, smaller than 360 degree. And now if I extend the angle up to 0 degree, x smaller than 450 degree, it would cut through the graph at 3 points. So here's called the angle C, so equal to cosine. All of them are equal to 0.3. And now if we put the graph of cos x and sine x together, we will have some new property. So look at this one. The red line, the red graph, would be for the y equal to sine theta. and for the blue one, before the y equal to cos theta. So when you look at here, you'll see that the cos of 20 degree equal to the sine of 110 degree. Sine of 110 degree. And one more, you can see that when you have the cos of 120 equal to the sine of 210 degree. So we have a general rule for that. So we have cos of theta equal to sine of theta plus 90 degree. Let's say if I want to find the sine of 190 degree, it will be equal to the cos of 100 degree. Because you take 190 degree minus 90, which is this one in the formula, so we can be able to know that the sine of 190 degree equal to the cos of 100 degree. And now we'll look for the tangent graph. From the previous video, you also noticed that the tan of 90 degree equal to 1 over 0. This one's undefined. So there are no values for tan equal to 90 degree. So for any angle in the form of 90 degree multiplied by n, like n is an integer, it can be positive or negative. It can be like -1, 10, -100 or something. It must be an integer in this form. So the value of the is undefined. Like 10 of 360 degree is undefined. We have no value for that. Undefined. Or the 10 of minus 540 degree is not defined too. It's not undefined. So please remember this one. So here the graph of the tan graph. Here's your minus 90 degree. Here's 90 degree. Here's 180, 270, and here's 360. The graph. So we will draw some dashed line. Dashed line here. Dashed line. Dashed line. And dashed line. And now we will draw it. So look at this one. You have the graph of tan, and it will be something like this. We have a lot of them. Okay. The red line are the graph of the tan theta. Okay, but z line will never touch the dashed line, because for the values of any angle which is theta equal to 90 degree multiplied by n, and n is an integer, we don't have the values of that tan. So z line will move really close to the dashed line, but they will never touch the dashed line. So they are called the asymptote. For the tangent graph, it had no limit like -1 or 1 minus sine, cosine graph. This one will go to positive infinity, and this one will go to negative infinity with no limit. Let's say I have here is phi. Tan of theta is phi. So it will depend on the range that we are judging. If I have the interval x greater than 0 degree, smaller than or equal to 180 degree, this line will cut up to here, but it never can touch this one because its limit is from 0 to 180. So it only cut the graph once at this point. So we work out the angle of this one. But if we extend the range from 0 to 270 degree, it will cut the graph twice, and it will be this point here. So we have two values of tan. So depending on the interval, so we will find the numbers of tan theta, which is appropriate to the interval.